Okay, welcome to software testing, and this lecture is system testing, and let's see if the technology that makes such a lecture possible will sustain itself during the entire lecture. So, system testing, this lecture is more or less aimed towards assignment 2. So assignment 2, if you have read it, is more or less a test effort for a product. So you form a group and you get an assignment to test a product for a specific scenario, and then you come up with some kind of test strategy. From this strategy you formulate a plan, and then you work with different risks, and then you do testing according to what we've learned in this course, and finally you want to communicate what you've done so that other people can see that you have done a good job. But before we step further into this lecture, let's make sure that I'm heard and can be seen. So if you're listening in on this, please write in Slack if you can hear me. Thank you. Awesome. Okay, so let's take a look at assignment 2. And oops. As you probably understand by now, it's more or less, since assignment 1 part 2 is optional, there are probably a portion of the students who are working on that assignment, and for the rest of the students, I want you to start with assignment 2 directly, even if we have not really stepped through all things during the lectures that is needed for assignment 2, because assignment 2 is a big assignment. It can be very big depending on how large your group is. But let's take a look at this one. So during this assignment, you will write a testing strategy for an application given a scenario, requirements, and source code. Then you will plan how the testing will be done, and you will write manual test cases and conduct testing of the application and report the results. Note that you don't need to fix any bugs. There are bugs in this software, so I mean there are things that you can find that are problematic. That are things that you can decide is problematic also. I mean, but let's step on to that later. But you don't need to fix these bugs. You don't need to fix the software or finish it or really write code here if you don't want to. But in order to test something, you need to run it. So just like for unit testing, in order to test a system, if you have an application, you need to run it, which may take some effort. This is a legacy software, so. But let's take group assignments first. So this is an assignment with 3 different tasks, and the first one can be done as a single student or in a group of 1 to 4 students. You can work alone if you want to, if you prefer to. You can work in a group. You are expected, if you work in a group, to do more work than a student that works alone. And this must be visible in the artifacts that you create, in the plan, in the actual testing that you're doing, and in the different things. So I'm thinking like a minimum amount of work would be like 20 hours of testing, something like that. Maximum amount of work would be like 40 hours, and I'm talking per student. So if you're 2 students, it's around 40 to 80 hours of work. If you're 4 students, it's suddenly 80 to 160 hours. I mean 4 weeks of man weeks of work. So you need to like divide the work between you. You need to, everyone cannot participate in every decision. You need to plan, give yourself different roles and plan this. I mean, there are different goals for this from the course curriculum. And yeah. And you're supposed to test different things. I've given you a couple of links to theory that can be good to read up on, and then the first task. So this is the task that you do in group, and the other two tasks you do alone, even if you worked in a group for the previous task. So you get a small scenario. So there is a made-up scenario, which is a small company called a software development company. And they think that they have found a market niche where they need to deploy a small, simple to deploy web server. This company aims to redistribute this server on a wide range of Internet of Things devices. So I mean, these are like small mini computers, mini servers that can be distributed. And they have sensors and stuff like that. But they're going to communicate, and they need a web server to do that communication. So this company wants a Java web server that can be deployed on many different devices. And yeah, so there are a couple of things in this scenario. And I mean, read this scenario, think what it means to you, ask questions if you need to. But really, much of the scenario is not really written in this short text. So you need to fill in the gaps yourself a bit. I mean, use your imagination, think if this was a real scenario and you get this job, and think what the stakeholders are here, and think what this could mean, and what kind of testing you need to do to accommodate what you found out. In a way, it's a good thing to write the different things that you decide down when you read this. So if you decide that this probably is going to work on Raspberry Pi or whatever, then you write that down. SDC have found abandonware software. It's a really software that I've written. So it's called My Web Server. And it's abandonware, which means that there is no support. We have found this on GitHub or found this on some place, and we can use this. We hope that we can use this. We have looked at the specification and perhaps seen things. And they need to know if this abandoned software fulfills the requirements as stated in the requirement document. So apparently there is some requirement attached to this, and these can be found and read here. There are requirement documents, and in order to test if this works, you need to read these requirement documents, because you're going to check if the software and the code that is provided is compliant with the requirements. That is your job. There is a bit of imagination that can be done here. I mean, there is also this scenario. So you as a tester need to activate your higher brain functions in order to think, does this also work for this scenario? Will this software work for this scenario? I mean, there are things that come with the scenario. And in order to test this, as some of you have already learned, you need to understand a bit on how a web server will work, what the requirements mean, and stuff like that. So you probably need to ask questions, read up about this subject. You should not assume that everything that you need is written here. Depends on who you are, what your experience is with web servers, if you've ever deployed a web server or not, and stuff like that. And you're also given the application source code, and it's on GitHub. Oh, there's some kind of documentation. Nice. So I've written a to-do list for you. So you're supposed to write a test strategy, a plan, manual test cases, execute the test plan, and report the testing. So if you're more students than one student in a group, then you probably need to do more work in all of these, but mostly this part here. And the way that you can expand this project to accommodate more students is by doing other types of testing also. So you don't only write manual test cases, you can also do automated unit tests, or you can use some kind of software for testing web servers and try that, or use Apache JMeter to do some stress testing on this, or you can do security testing, and you can read up on different subjects. So there is a lot of freedom to do fun stuff here. In the end, you're delivering a couple of different documents, and these are the documents, and we want those as PDFs, and then we want you to zip this, and not a tar archive or something like that. It should be a zip archive. And there are a lot of different rules for these. So the second task of this assignment is to write reviews on other people's work. So when you've written one of these and you've conducted testing on this, then you're sort of an expert on testing this system. So you probably have done things differently from other students, since students think differently, which is fine. So next step is to learn, okay, what have other people done? And what I hope here is that you encounter hopefully some group who has done more work or other things than yourself that you can learn from, but also that you can think of how a test effort can be communicated. A lot of the things that we do in testing and in software development overall actually is communicating. To have a clear communication from one person to another person, or from one person to a group of other persons, or from one group to another group. So the kind of documents you're writing here should be good at communicating. And what I want here is that you should make sure that your document looks like you've done a good job. So you should present your work in a way that it's readable. So we review the clarity, which means that we need to have good language. We need to write in English because that's the course language. You need to work on your spelling and grammar. So use these tools that are available. I'm using Grammarly plugin for the browser. I think that works pretty good. So do spell checking, do grammar checking, do proofreading and stuff like that. You should format and lay out your document. It should use tables, links, titles, different levels when appropriate, different levels of titles and stuff like that, to make bullet lists, things that makes the documents easy to read and easy to access for other students. Because if we have, like this assignment, huge text blocks, it's hard to read these. It's hard to find out if, find the information in them. So break down things into different headings and stuff like that. It should have a good disposition. That means that the order of chapters or sections should follow naturally. So we can read these documents from the top to the bottom and don't need to scroll back and forth to the end of the, and lose ourselves. And there are things that should be in these documents, like the test strategy, so should describe stakeholders and their testing goals. We're supposed to look into that now, more or less. The test plan should outline what should be tested, and really it should be a plan, who does what when, and what should not be tested, and stuff like that. And then finally, there should be a review of the content of this, which means that when you have done this testing yourself, you know approximately how much time you spent on that, and given that, how good a job did the other group that you're reviewing do with their time? So if you did more work alone than a group of 4 people, then probably they could have done more. Look at their plan. Did they do a good job given their resources? And I think that if we must include some learning into this, into these 80 or 160 hours also. Of course, we need to do that. And there are some overhead with being a bigger group and stuff like that. But really, you need to make sure when you write this document that you are showing the job that you've done, that you truthfully show that you've done a good job. And finally, you're supposed to read these these reviews that you've received and give feedback back to the students who have written those reviews so that they can become better reviewers. So that is more or less the assignment 2. So we need to learn a bit about testing strategy to start with. So a testing strategy is really, a strategy is to reach some kind of goals. So we need to find what are the goals of the testing effort that we're going to do. So some of these goals are from the requirements and from the scenario. So look at these requirements. Okay, we need to find the gap or the difference between the implementation and the requirements, and we probably need to find some other goals from the strategy. And the second part of the strategy is the means. What do we have? What kind of resources do we have in order to fulfill these goals? And I mean, this depends on you. What you know, what kind of toolings you have, and stuff like that. So this was an Internet of Things scenario, but perhaps you don't have a Raspberry Pi. Perhaps you don't have more than one computer. Perhaps all the group members have the same operating systems. Perhaps they have different operating systems on their computers. Perhaps they can borrow another computer with an operating system. So find out what kind of means do we have in order to do this. But we need to read these requirements first because we need to find out what kind of testing goals. Means is also the work hours that we can spend. So look at your schedule. You need to look in your calendar and you need to plan time for this. So I mean, I've given you 2 numbers between 20 and 40 hours. I would prefer that you plan 40 hours into your calendar for this assignment before the deadline, before the first deadline, and then use less if you need to, or if it wasn't really needed. So look at your calendar, see how much time you have. And it also means that looking at time, I mean, some students might need to work in the evenings. Some students might need to work in the weekends. Some students need to work during the day and cannot work in the weekends and stuff like that. So if you're forming groups, you need to make sure that these groups can at some points have meetings regularly, at least, or that they are available at the same time. Because the most frustrating thing in group work can be if you don't work with the same resources, so to speak. So if I'm working in weekends and you're working during the weekdays, probably we should not be in the same group. It may be better if we split up or find other students. So I've formed a thread in Slack. I have not looked into if someone used it yet, where you can ask for group members. So say perhaps ask for group members there and say also something about your means. Really, okay, I can work in the weekends, or I can work in the evenings, or during the days, or whatever. And I think it's a good thing within the group to have a discussion, like the first meeting that you have a discussion. Are we aiming for the same goals here? What kind of grade are we looking for? What kind of, what do we want with this project really? And if you want different things, perhaps it's better to split up. if you want the same things, good. Then agree on this before. Agree on your terms. So, okay. So when we have goals and means, we can form a strategy. And the strategy is to reach the goals with the means that we have. Sometimes it's so the minimum thing here included in the strategy is to write these manual tests. But perhaps you're more interested in automating tests, because that's where probably the most useful skills sets that you can learn in this course is to automate these using different tools. Perhaps you want to try out tools for stress testing web servers or stuff like that. So include things into the strategy that you want also. It's much more fun, much more engaging to work with things that you like, that you find fun. Okay, in order to find goals, we need to think of what is at stake. And we used to call people who have an interest in a project, we used to call them stakeholders. So I mean, in this case, it's SDC, and perhaps that is the primary stakeholder here. Then, if you read the scenario, then you probably can find other stakeholders within the scenario. You can also like imagine stakeholders. So we have the SDC company. Perhaps there are people within this company, like developers, like marketing. They are like wanting to sell their things to other developers. Perhaps they are also stakeholders. And then you think of what are their testing goals? What do they want to work, and what do they need to know about this software really? So in this case, I have an example with a web shop, and we have found for a web shop, and this is not related to assignment 2, for this web shop where people are supposed to shop, we found stakeholders, the web shop owners. They want the process of shopping tested every day. So that is the testing goals. They need to have something that is easy to test, and they want regression testing to be fast because they want that tested every day. So I think having that, not only the stakeholders, not only the requirement, but also something about time or something like that is a good thing to have in a goal. It should not take forever to test this, because we need to test that every day. We probably, with this goal, we probably need to focus on automation. And then we have the means part, and that was sort of the budget for this. What is the time available? Who are the people available? And in assignment 2, I think it's a good thing to give each other different roles. So perhaps you have some test lead or like that, because I want these documents to be anonymous. So use role names instead of, and just make up these roles really. And equipment and perhaps other things also. I mean, do you have access to testing experts? Do you have access to domain knowledge experts? And actually you do have access to domain knowledge experts and also test experts, because you have access to me through Slack. And during the tutoring times, you also have access to the tutor instructors, which have done this before and know some of the pitfalls in this. So, I mean, these are also means that you can include in your strategy. So the strategy part. So what is our strategy to reach these goals with our means? So, so the example from, since the application is relatively stable, if you know that, and deployed also, we want to test the shopping requirements in use case 2 using fully automated system test. These should run nightly to ensure availability and uptime. So that was the strategy that I came up for this web shop. So we have not spoken about use case 2, but you're connecting the different testing goals with the means, and you're solving the problem really. And in strategy, if you're working in an agile project, you're probably not doing all testing the first iteration. You probably want to divide the effort between different iteration of the project. So if you're working in like 2-week iterations, then you're dividing your work, your test effort between these weeks, and you're building gradually more and more automated tests, for instance, each week. Probably you want to test things that was implemented during that week and stuff like that. So for an example of that, in this iteration, we focused on the ad system API, since the developers released a new version of that. It makes sense to, if you have released a new version, we want to focus our test effort on that, because we have not done testing on that before. But we also run regression tests on the login system that was updated. So we have updated one part and we've done a new part, and we test both. And regression testing was to rerun tests that we've already written and tested once to make sure that things didn't break. Yeah, so now that we have a strategy, we can do a plan. And the first part of a plan is what? What should be tested? Which requirements? You have many requirements probably. Which are the important ones? So you need to do some kind of decision here. And I mean, the strategy should guide you here. So, okay, we need to focus on these things in the strategy, so we select the requirements that are most important to reach that. And requirements can be both functional and non-functional requirements. There can be static and dynamic qualities that we want to test. And dynamic qualities are things that when we run the system, we find out. So most functional requirements are dynamic qualities, because we run the system and we generate a test case from a use case, and then we find out if the use case is implemented as it should be or not. There can also be static qualities, like doing code reviews of the source code. Code reviews is a really good thing in order to get stable or good code, but perhaps is not a part of this course. Code reviews can be really good to find bugs, and that is also our goal with testing, right? But we're not going to step into this, and not every student is an expert in Java. So you really should not need to read much of the code. You might need to read some of the code in assignment 2, but you probably should not need to read all of the code and understand all of the code, depending on your strategy, of course. You need to do some prioritization. Is there any part of the system that is more important? Perhaps there are things in the scenario that says that this part of the web server that we're going to test is more important that it works than other things. Since we have developers in this software development company, perhaps they can fix some of the problems. But if the source code is not available, for instance, or we cannot use it for some reason, then perhaps that is important to find out, because then it's a showstopper. If we're implementing this system ourselves, which part did we implement? So if we just implemented a part, we need to test that part more thoroughly. If we change the part, perhaps we need to regression test that again. So what should be regressed? What did fail last iteration? We need to rerun the test again and see if we fix those problems. What code components have been updated? And here is an important word: traceability. So traceability is going to be one of the things that we look for in your document. Traceability is the ability to link a test case to a requirement. So we need to have some kind of way to say that since this test case failed, the requirement also failed. And preferably, we also want to have traceability down to the code that implements the requirement somehow. But more on that. We also need to describe what should not be done. If we're going to make sense, and some reader is going to read our documents, and they need to understand why we didn't test some part. So we prioritize this part, and because it's new, or because we've updated it, or whatever, or because we don't because we find it important. But we can also write stuff about things we don't test. If we have a good visualization of all the requirements, we can clearly show this, perhaps with colors, what we test or what we intend to test or not. And we need to motivate these also. Why didn't you test this requirement? So now we're done the what. Now it's the how. How should we test things? What kind of test level should we write our test for? So, and the test levels were more or less unit testing as the lowest level. While we write code, we also write unit tests. And unit tests, I would prefer those to be automated so that they can easily be regression tested again. And I mean, it's sort of the focus of assignment 1, and it's the focus of assignment 1. But you can also have integration tests, and these can also be automated, of course. More or less all of these tests can be automated. Integrations test is when we test different parts of the system together. And it's like if we have a server application and a client application, we test these together. But it can also be we test these 3 classes together. We write a test where we test all of these classes together. So you probably in assignment 2 should find out what kind of testing should we do. Should we do unit testing? Should we do integration testing? Is there any test effort already done in this project? If we take a look at the source code or the requirement documents, is there any testing done? So find out if that is done, and perhaps do it again, regression test that, see what the test results is from that. See how well that testing was done. Do we have coverage? Run these tests with coverage perhaps. And we can also do manual testing, and finally we can have acceptance tests. And I think the manual test and acceptance test is something that more or less is assignment 2, the focus of that one. But I can reveal that there are unit tests in the source code that you get. So I mean, you should run these tests and find out what they give you. On test levels, we can also have like beta testing. Like we do a release of this software, we give that to some group that are representative of our customer group, and see what they find out from this. But yeah. And then when we know the test levels, then we think of the technology thing. So what kind of technologies should we use? Should we use, what kind of framework should we use? What kind of tooling should we use? How much, yeah. So for automation, okay, we're going to use JUnit and JMeter. We're also going to run each manual test case manually once. Perhaps you want to do some exploratory testing. I mean, James Bach was fun when we looked at that video, and I've always wanted to bang the keyboard with my shoe. So let's do some exploratory testing and see what happens. Should we involve the customer in this? Really, in this project, it's up to the group to do the testing. But I mean, the group could employ some other people, the spouse or friends or whatever, to test things, to run the test. It could actually be a good thing in the sense of communication to let one person in a group write the manual test and another student conduct the testing, read the manual test and do the testing from this, to make sure that you actually communicate in a good way. We've talked about flaky test cases, and that test cases can be ambiguous. And I've shown you example during one of the first lectures that I've written test cases that are ambiguous and that different students get different test results because they interpret the test case differently. So to make sure that you do a good job, I could recommend that. Okay. Okay, next part is to find out or to show really that our testing was a good job, was well done. And this is extra important. Okay, this was not that part. How do we judge that the test result to be okay or not? And I mean, testing should guide some other effort. So testing gives us information so we can do something else. So testing was building knowledge of a system, and that knowledge is going to be consumed by someone. So we need to find out, is this a good test result or what? If we run 100 tests and 95 of those succeed, is that a good result, or is it a bad result? And it's sort of you need to think of who is going to receive this test result and how are they going to use this. So if the stakeholders have highly set goals, perhaps there are lives at stake, then we are much stricter on how we interpret 95% of the tests succeeding. Then that's suddenly bad. If it's the most important test cases are succeeding and we have 95% of the tests succeeding, then we think that, and it's not so life and death situation, we won't lose money right now, then we think that's fine. So I mean, if this is good or not depends on the stakeholder's goal. And I mean, programmers, for instance, maybe they know that if there are tests and these tests are failing, I can fix that. So for them, it's not a problem if we have a unit test that is failing, because they can fix that. Instead, they want to make sure that they have a high coverage. So for them, it's more important that we want high unit test coverage. And if the coverage was low, then this report that you write should be read by the unit test lead, or the lead of the programmer lead, I mean, so that they can decide on that. Okay, if we have a multi-iteration project, then these iterations are linked together. So we do some implementation in one iteration, we also do some testing. The result of that testing is going as input into the next iteration and is going to lead the work there. If everything worked, then we don't need to fix bugs and stuff like that. If we have a bug report or many tests failing, perhaps we need to to fix a lot of bugs before we progress. So, and in the end, we might want to focus our testing effort to some things. Some things are more important than others. Perhaps we need to include the customer into that decision. So in this example, perhaps the customer wants all the main success scenario to succeed in this first iteration. So we say that, okay, test case 1.0 and 2.0 should succeed, but it's not a big problem if the other test cases fail. And if these fail, then this guides our testing effort next iteration, so that, okay, next iteration, we need to focus on these. So you as a tester, you sort of guide work or generate information that is input to other people or to the developers for the next iteration. And I mean, the same thing goes for assignment 2. So you are more or less supposed to come up with some kind of decision if this is good or not, but also suggest action. Next iteration, I recommend that we're going to use this web server, and next iteration we need to focus on these things. These are the flaws of the web server that we found out, so we need to focus on these things. Yeah, so then we come to the who. So it's still a plan, guide, work, effort. Now that we know what we need to do and how we're going to do it, then we need someone that does it. So who is responsible, who's going to implement the test, who's going to run the test. And I think that working with who has the information is a good key to this. So if we have an expert in writing unit tests in the group, perhaps that person is the person who's supposed to look at the unit tests. If we have a domain expert, perhaps that is the one who's going to write the acceptance tests and stuff like that. We also need to think of who uses the result. So for each of the different things that we're going to do, assign one. So I want to see that the different roles that you come up with get assigned hours more or less and things that they're supposed to do. Okay, those were the good parts, and now we come to the risks. One of the problems with assignment 2 that I've already seen, because someone said that I don't know much about web servers, we've never deployed a web server before, I don't have read anything about web servers in a previous course, so how can I test web servers? So this is a risk, because since you're not a domain expert on web servers, then this will affect your testing. And the risks and assumptions are things that can affect our test process negatively. So perhaps we need to make sure that these risks are mitigated. So as part of the plan, we also need a mitigation strategy. This means that how do we minimize the risks and the effects of this possible problem? These can be things like someone in the group can get sick during the testing. That could mean that if someone gets, that means that we, in order to mitigate that risk, perhaps other people need to cover for that person if they get sick. So since there are a couple of weeks until the deadline, if you start early is also a way of mitigating risk. Giving yourself more calendar time. If someone gets sick, perhaps they can work a bit later. But risks can also be things like prerequisites of test effort and test environment. What if you don't have access to things when you need to do that you need during testing? So if we have this web server at the customer's thing and we need to test on their hardware, what if we don't have access to that hardware? What if we cannot log into their system? There are things that we need to get in order to mitigate this risk. So perhaps we need passwords, perhaps we need to set up private networks and stuff like that in order to get in, tunnels to get in. There might be things that access to test-specific equipment and test personnel. That you need access to people. You need to plan for these problems. So a part of the test plan should be about the risks and what assumptions that must be fulfilled in order to do this testing. Really depends on you much and the kind of test effort. And I mean, in this project, I think learning about web servers, how they work a bit, is a good idea. You probably don't need to spend like 20 hours on this, but I mean, starting a web server, seeing how it works, reading up on it on Wikipedia or whatever, could be a good spent hour in the beginning in order to find out what we're going to test. Okay, so that was the plan. And a plan is about communication. And I want you, when you write these documents and you read these documents in order to see if they're good or not, think of the person who's going to read these documents. See if, am I really communicating what I'm trying to say here? So there needs to be some kind of information transfer between different parts. So one way of thinking when you write the plan is that someone else is going to read this and do the work without any other communication. Because when you're going to review other students' plan, you want to understand their plan, right? And you want these other people who's going to review your plan to understand what you are doing and see that it makes sense. I got a question, should we have a time log? I think you don't really need a time log for this, but I want the hours planned ahead. So you do a plan and you write this, but you can include a time log. A time log is sort of a way of communicating, we spent this much hours. And that sort of can explain things like we could not do as much testing because this problem happened. And we can see that in the time log. So go ahead and use a time log as a tool for yourself. I think that is the good thing. But if you're only like writing the hours in the time log afterwards and never measured, then it's a useless artifact. Then, yeah. So a focus on clarity and communication. So the one who has written this, make sure that someone else reads this, or read it the day after and see if it's readable and understandable. Finally, or more or less, we need also to present the results, and we need to present how which tests that succeed and fail. So you're going to have this test result document, and we would also get some higher analysis of the test results. So you need some kind of traceability to requirements. So let's, yeah. So if a test case with a certain name and number failed, we also need to know which requirement was connected to this. But really the test report is more or less a list of tests and if they succeed or not. When we write the test results, I've already communicated some of these, but when we write the test results, we need to think of the reader of that one. Who is going to read this? What kind of action is going to be done with that? Where is it going to be stored? How should we act on the test results? So if of your test effort, who's going to receive that test report? Who's going to get it on its table? What kind of decision is going to be made with this test report? So are you going to give it to your boss? Then perhaps it needs to look like you did a good job, because the only decision that boss is going to do with this is that it's going to find out if your salary is going up or down. If you're going to give this to a developer lead who's going to decide on what is important next iteration, then perhaps the test result is differently formed. Perhaps it's very clear which part of the code is connected to this test case and stuff like that. If there are activities that needs to be done, we need to rewrite this part of the code until next iteration, because this stops our test effort. Perhaps that should be clearly stated and thought of when you write this. I mean, this part is very individual for the different project and for also from the result that you get. Okay. So I've talked a little bit about requirements. So now we should start with building tests from requirements. But before we start with that, I think that we need a 10-minute breather. So welcome back to software testing, and we're talking about system testing and how to test requirements. So this is the requirement pyramid. I've taken this from IBM. So there's a link here where you can read up on it. So in the top of the pyramid is where we start, and this is a bit fuzzy because it's the needs or goals of the customer or the people who are stakeholders in a system. So, and I mean, the needs can be pretty fuzzy and probably not super strict communicated, because I have a need for this and I have a need for other things, and these change also. And sometimes we think that we have a need, but when we actually realize the system, we realize that we had some other needs and stuff like that. So it's a bit fuzzy, and therefore I've used small clouds up here because they're not really that strict. From these needs, we can extract or we can write down features, and features are bigger things like I need to log in. For instance, I need to have some kind of authentication, so I have an authentication feature. And below the feature, we implement features with use cases. And you can see these lines are connecting features with different use cases. And these may be cross-referencing. So several features can be implemented in the same use case. And one feature can have multiple use cases. On the right-hand side here is not use cases, it's more specification, supplementary specification. It can be things like, in order to have an authentication system, that needs to be secure. And security is, maybe parts of security is, for instance, that it should not be susceptible to different types of attacks. So we write down different types of attacks that we want to protect our authentication system from. And we don't really create use cases for those for some reasons. It can also be other things. In order for a feature to work, perhaps we have a non-functional requirement that is that the system should be user-friendly, or the system should be responsive, or it should be responsive under load and stuff like that. And we write those in this supplementary specification. So assignment 2 have requirements. It's divided into these parts, really. From these use cases, we derive scenarios. So these are, I'm going to talk more about scenarios in a moment. These are steps or paths through a use case, and then each scenario is mapped upon to a test case. So in the bottom of the screen here are the test cases. We can have multiple test cases for one scenario. For instance, if we have the scenario to log in, we can have two different users that are logging in. Perhaps we're logging in with user A and user B. It's the same scenario to log in. And this specification can also lead to test cases. For instance, that we're doing for the web server, perhaps we're doing some load testing. We see how the web server behaves when we have 10 calls per second or something like that. There can be test cases that are derived from specifications like we need to check if the source code is of a certain language. There can also be test cases that are not directly connected to a requirement. That you find out, oh, we need to test this also. But these should be the exception, and probably we only have these because we've forgotten things up here. So we didn't think of these things. So we found out things about the system when we conducted testing. Testing and as many things that can be planned does not go always according to the plan. So we find out new things. So here we have an example. So we have an example that a user wants to get access to a restricted system, I think. I mean, that is sort of the need of the customer. They want that is their need. And we have a use case which is more or less this. User requests access. System asks for credentials, that is password and username. User gives these credentials. System verifies the credentials and presents restricted access. So this scenario or this use case, when we read a use case, it's a story on how someone gets something from the system, how they get some need that they have fulfilled by the system. Or we call this the main success scenario. And then we can have alternate scenarios, which is if the user gives invalid credentials, then the system presents that the credentials are invalid. So we have one need. We need to access to restricted stuff. That is probably a feature in the authentication system, which leads to one use case for logging in. And then we had a main success scenario for which we have two test cases. And then we had an alternate scenario. What happens if we are giving the system invalid credentials, the wrong password? Then we have a test case for that also. So when we want to create test cases, we use the requirement documents. And probably it's a good idea to write down the use case as a graph with different steps. So for instance, here we have a graph with a couple of steps. So perhaps this is the step where the system asks for credentials, and here the user gives the system credentials, and if the credentials are correct, we get into the logged in state. If we're not correct, we get back to this one where the system asks again. In order to find out something about the system, and in order to find out if the system is implemented all these paths, we probably want coverage over all these paths. So here is a use case for authentication. So we can see that in step 1, use case starts when a user wants to authenticate. Step 2, system asks for username, password, and if the system should save the user credentials. Step 3, and you can see step 3 is down here. User provides username and password. And step 4 is the successful login. So 1, 2, 3, 4 is the main success scenario. Then things can go wrong, and we call these alternate scenarios. So 3A is that user wants the system to keep user credentials for easier login. So in step 2, the system asks if we want to save your username and password into the system. And if the user selects that, then we get into 3A. And the system, when we get into to 3A, and if we're successfully logged in from this state, then the system will not only authenticate you, it will also present a message that we're going to remember you next time you log in because we've saved your credentials. But we also have a separate step from 3 and from 3A where we could not be authenticated. And in this case, we want to present an error message, and then we step back. So in order to cover this use case with test cases, we need to create a few test cases. We need the main success scenario, 1, 2, 3, 4. We also need sort of the second successful scenario where we log in, but we want our credentials kept. So 1, 2, 3A, 4. And if we mark all the lines that we stepped through, then we realize, okay, we have this path, and this path still to cover. So we need to have one test case for 1, 2, 3, 4A, 2, 3, 4 perhaps. And another test case for 1, 2, 3A, 4A, 2, 3A, 4. And then suddenly we have path coverage at least. So all paths are covered by test cases. Yeah. So in the end, we need to think of the different things, the different paths we can take through this. And if we have a loop, like we do in this one, we can come up with many test cases. I mean, we can have an infinite amount of test cases. We can actually step through 1, 2, 3, 4A, 2, 3, 4A, 2, 3, 4, and then 1, 2, 3, 4A, 2, 3, 4A, 2, 3, 4A, 2, 3, 4, and then we can continue like that forever, right? And perhaps some of these test cases can reveal bugs, but in the end, we will reach a point where adding more test cases is useless because we won't find any more bugs. Of course, there are also an infinite amount or more or less of implementations that could have bugs that could show up after 10 loops in this. Perhaps we're using memory and the memory grows, the memory footprint grows and grows and grows and grows. But the more frequent the bug, the less number of test cases we need. The simpler the code, the less number of test cases we need. And after a while, we have enough test cases that we feel that we're probably gonna catch all bugs. So I would say that depends on the number of test cases that we add, or the number of scenarios we come up with, depends on what is at stake, and also how much time do we have for testing, how much resources do we have. We cannot do 1 million tests because we don't have 1 million hours for that. Okay. Finally, we want test traceability. And we want test traceability in order to show what parts of the system did work, did not work, has been implemented, which part of the system contains the problems or the bugs or the and we also need test traceability in order to show that our testing focus was actually reached. And if the system changed, we want test traceability in order to only test perhaps the things that changed. So in order to get test traceability, I would recommend for assignment 2 to use a test traceability matrix. It's really a matrix between requirements and tests. And so the requirements are these are the use cases, and then we have some technical requirements or supplementary specification requirements. And we have some code here, and then we have test cases, and we can see that requirement 1, use case 1.1 is covered or partially covered by test case 1.1.1. My suggestion is that a test case is its number or its code is actually based on the use case. So 1.1.1 means that it's a test case of use case 1.1. This way we can see that you can also see that in total we have 321 test cases. Requirement 1 is covered by 3 test cases, this one, and this one. 1.2 is covered by 2, this one and this one. So if we look up here and we see a 0, we know that that requirement is not tested at all. Yeah. Yes?
Are we supposed to perform these traceability matrix multiple times?
So I get the question, are we supposed to perform this test traceability matrix multiple times? So this is a tool to guide your test effort further. So if you, like, we are halfway through A2, and you want to know, did I cover everything? Then you create this test traceability matrix. You find some zeros and see that these requirements are not tested. And then perhaps, okay, I'm going to introduce more tests for these. But in the end, I mean, you're going to send in this, your manual test cases and your these documents, and that is what is going to be judged on. And I don't think that anyone really wants to see the progress up towards that. So you don't need to you can do it for yourself, but you don't need to do it to present to others. If you do it for yourself, you can still write that we did this, or we're gonna, each week we're gonna do this. I mean, that's a way of showing that you care about it. Okay, there are some links to this and different ways of doing that. And I've talked about the functional requirements more or less, because functional requirements was these testing use cases really, and deriving test cases from scenarios and coming up with one of the things that I didn't mention here is that we need test data for each of this. So in order to get this path 1, 2, 3, 4, you also need to provide this username, password as concrete user data. So you need to write test user 1, correct password 1, not checked, for instance. That is test data. But there were other requirements, the non-functional requirements, and there are a lot of different types of non-functional requirements. And we're more or less unable to cover these in this course because there are as many test methods as there are different names for these. So I think let's look at this one. yeah, you can see there are a lot of different non-functional testing, like compliance testing, like document testing, like endurance testing, like load testing, performance testing, recovery testing, security testing, scalability testing, stress testing, usability testing, and volume testing. So what I want you to do is step through these on Wikipedia once and look at these and decide if you want to do some of these for assignment 2. So if you're in a larger group, I think that you should at least do some of these. And I mean, some of these don't need to be very, you don't need to do much work, and other things needs more hours spent, so to speak. Compatibility testing, we could say that we're doing compatibility testing by testing different web clients towards this web server to make sure that it works. So, I mean, set realistic goals, and many of these techniques need specialized tools. So one of these tools is Apache JMeter. And Apache JMeter is a tool which can connect to web servers and can send different commands to these web servers through HTTP. And it's you can configure this to many different scenarios, so to speak, and you can conduct load testing and stress testing and stuff like that with JMeter. You can send very specific HTTP commands to the web servers. You can have like simple GET request, I want this web page, and then you can say that I want this web page every 10 seconds, or I want this web page 10 times each second, or something like that. And you can watch different graphs and stuff like that. So I think JMeter is a nice project to like look into for web server testing. But go through these first here, read up on load testing and scalability testing and stress testing, and see that you know what you want to do, really. And then look at JMeter. There are probably other tools if you write things like stress testing web servers or stuff like that. And finally, students are usually asking for different templates. So let's see if this one is, no, it's not working anymore. Huh, good. And this one? Oh, it's asking for stuff. I'm not going to do that. So the thing with templates is that I don't think that they are required for assignment 2 to have a template for this. I think that you should use your frontal cortex in order to find out what are the good ways of communicating this. And then you're going to test your communication by reading your own documents. Does this make sense to someone who has not been a part of this group? Do I make myself clear here? And the problem with templates is that they include much more things that you probably don't need. Yeah, there are probably ways of finding these documents, and I have not clicked on this for a year, so. But I think write your own instead of using templates. The templates are good because we can get inspiration from these, but they also include a lot of things that I think is useless in assignment 2. Okay, that was more or less this lecture. So thank you for listening, and see you on Slack.